Hi everyone. So welcome to this short video. This is actually just a follow-up on some of the concepts that we have been discussing in class. And I got this question several times in office hours, so I decided to kind of just clarify this. So what I'm basically interested in just explaining a couple of things which I felt were maybe not as clear to students. And so first thing is that whenever we do buoyancy calculations, there are two approaches. Okay, so the first approach is the Archimedes principle approach, and that is weight of the fluids displaced by the solid. And when you do that, you can use basically the Archimedes principle to calculate buoyancy force. And this is always upwards. Okay, so this is always upwards force. And the second approach is the pressure calculation. So net pressure on all surfaces. So net pressure force on all surfaces. But I'm only talking about submerged systems. So this will only work if somebody is submerged, okay? Not something which is on the side or anything like that. In that case, you don't have two approaches, you only have the pressure force approach. So when somebody is completely inside a liquid or half of it inside the liquid, that is when it's submerged, that's when you can essentially use this. And so I always recommend first using this approach, okay? Because this is easier. It just directly wants you to calculate like a weight of the fluids displaced. However, this also leads to this answer, and that is what we have been focusing on a lot, right? How you can show the net pressure force leads to this. So we did an example on a cubicle, half of a cube inside a liquid last week. Then I recorded like a supplementary video on a triangular block fully submerged inside water and did a full calculation on that. And the third calculation we did is the left hand side, and that's the one we did last lecture on basically that a cylinder is submerged half in oil and half in water. And the whole idea was to show that the weight of the fluids displaced is the net kind of buoyancy force or the net pressure force. So you can just directly use the weights of the fluids displaced. However, from what I've seen and I'm kind of trying to understand, what one concept that most of the students tend to kind of were getting confused is, well, oil is sort of in the pressure force. We thought of sort of this part being, F top and F bottom. So we are now focusing on this approach. Again, I don't advise this approach. This is just a clarification. So you will say, well, F bottom is F buoyancy is F top plus F bottom plus F curved. And then the curved part just cancels out. So that because it's symmetric, so the force pushes and it cancels out from the sides. So if it is top and bottom, then why when it's the top part is the oil part? So why should I have the weight of the fluids displaced by the oil pointing upwards? Why is the top, if it's oil is just at the top, then why is this not contributing to a downward force? So why should I include the weight of the fluid displaced as an upward force? And it's a good question. Basically, the confusion is coming because the kind of mixing the two approach. So let me try to kind of explain why even the weight of the oil displaced points upwards. Okay, so that is a key point that I want to make in this video. All right. So what I will do is I will draw these hypothetical layers. Layer 1, layer 2, layer 3. Okay. Maybe let's do another layer 4. Okay. So layer 4, 0, 1, 0, 1, 2, and 3. Okay. So there are 4 layers. And I just wanted to kind of think about this as a conceptual part. So layer 0 supports air, right? Supports the weight of air. Okay. Layer 1 supports air as well. It is not that air has vanished, but it is supporting air plus, let's call this distance d, plus d, like layer of oil with thickness d. Okay, so oil with thickness d. Then layer 2 is supports air plus, which is, let's call this h by 2, and this also h by 2, half and half, plus oil with layer with thickness d plus h by 2. So what the point is, the lower the layer you are going, it doesn't mean that it doesn't support the upper fluid. That pressure will transmit through, right? The pressure will transmit through the entire system. Let's keep going. Layer 3 will support air, this oil with thickness d plus h by 2, plus water with thickness h by 2, right? And thickness h by 2, right? So that's the key point. So as I'm going deeper and deeper in a fluid, I'm just supporting more and more weight of all the upper fluid layers. So if I'm inside oil, and even it doesn't mean that the air has gone away. It's still pressure atmospheric is still there. If I'm at layer 3 in the water part, remember I'm supporting now air plus full layer of oil and then also further water. So all the three fluids are being supported at that bottom part. Okay. Now I hope you can see, because the top force will push it down and the bottom force is pushing it up. You would agree, I hope, that this is layer 3 pushing it upwards. This is layer 1 pushing it downwards. Layer 1, right? This layer is the bottom part. So this is the top part. And then layer 3 is the bottom part. Right? So this FB essentially becomes layer 3 minus layer 1 in terms of pressure times some sort of an area. And this is approximate. But all I want to make a point here is that if you subtract layer 3 minus layer 1, you see the air support gets cancelled. Then the oil with thickness h by 2 gets cancelled and you get oil with thickness h by 2 times area plus oil plus water with thickness h by 2 times area. Okay, so you can subtract this pretty easy. Just subtract this thickness h by 2 times area. So both the forces are pointing upwards. Why? Because at layer 3, we have the full weight of all the upper layers, and the top layer is sort of subtracting everything. So whatever is in the middle between the top and the bottom, it's all pointing upwards because the bottom layer is holding all that upper weight. So even though that bottommost layer, the layer 3 is in water, it's actually also carrying the weight of oil. So both the weight of the fluids is placed of oil and water point upwards. Okay. So this is just to clarify that when we are thinking about pressure force, the net pressure force will always become weight of the fluids displaced, as we have shown in class. And that even though the top portion is in the oil, because the bottom portion supports the weight of both oil and water, the net force is always upwards. So there is never going to be a case when you will have a weight of fluid displaced pointing downwards. It cannot act with gravity. Buoyancy always acts against gravity. Okay. So calculate the weight of the fluid displaced and then point it upwards. Always point it upwards. Okay. So hopefully this give you a sense that the bottommost layer supports all the fluids above it. So even oil is pushing it, upwards. It's not net pushing it downwards. It's still pushing it upwards. So weight of the fluid displaced always points upwards. All right. Hopefully this video helped. If you have any questions, feel free to reach out. And I see you in the next lecture tomorrow.